You look at your wall outlet and groan. Plastic eyesores, clunky, outdated. But let me stop you right there. That ugly rectangle is a masterclass in controlled failure. See that third prong, the round one at the bottom? You think it's decorative. It's not. It's a dedicated escape route for rogue electrons. Without it, a faulty appliance becomes a taser. The current needs a path back to the panel. If it can't find the ground, it finds your nervous system. Enter the ground fault circuit interrupter. That little plastic button on your bathroom outlet. It's not a gimmick. It's a watchdog with a split-second reflex. Here's the loop. It detects a current imbalance. Just a few milliamps drifting sideways. It trips the breaker before your heart can flutter. 120 volts is no joke. But wait. Why do outlets stay bulky? Why not flush mounts and minimalist walls? Because electricity generates heat. Thermal runaway is real. The plastic housing isn't lazy design. It's structural stress management. Connectors flex. Wires expand. If you seal it tight, you cook the insulation. You want sleek? Go ahead. Buy those flush-mounted designer outlets. They look like furniture. They also fail catastrophically under load. Skill issue, honestly. And don't get me started on smart outlets. Wi-Fi enabled. Now you've added network latency to a safety device. You want your lights to buffer while you're holding a hairdryer. Engineering isn't about perfection. It's about triage. We patch one bottleneck, another pops up. Voltage regulation, harmonic distortion, fault tolerance. It's legacy code running on copper wire. The grid compensates. Capacitors store charge. Transformers step it down. The outlet sits there, unimpressed, doing exactly what it was designed to do since 1974. So next time you plug in, don't sigh. Thank the clunky plastic. It's keeping you alive while your phone charges. Drop your hottest takes in the comments. Stay safe, stay chaotic.